Alright, so this is a video on the neutral grounding of the Growatt inverters. So if you don't connect up the grounding contactor to a grounding relay, when you switch to battery and solar and you're no longer on grid, you'll see on this guy I've got that's light, that one is partially lit. That's because there's still some bonding. There's still some bonding, or there's basically not bonded, not completely unbonded between these guys. So what should be happening is that this light should be solid, this light should be solid, this light should be out. So what we're going to do is, I have this little relay here that I'm going to use. These is the power to run the relay. So this is using the dry contactor and option 24. This, when it's on battery, will close that contactor, which basically energizes the relay. And then on these two ports over here, I will have ground and neutral, and that will basically move the neutral bonding to the output side of the inverter, instead of the neutral bonding being all the way back at the main panel that's feeding the inverters. So when you're on grid, this will open up and your neutral bonding will be back at the original panel like it's supposed to be. When you're on solar and outputting from the inverter, it moves the neutral grounding to here where it needs to be just before your panel. That is the proper way, and then in that case you should have solid light, and that light should go out. So now I'm going to wire that up, the neutral and ground line, to that contactor, and we're going to test it out. Alright, so I now have the relay hooked up. I'm on solar. You can see that we are now in the correct solid out. This is what is supplying the power to that relay. So if I unplug this guy, oops, trying to do this without getting zapped in the process, hold on. And now the relay opened up, and you can see that is how it was operating when there was no relay in there. Put this guy back in, click. Now my ground is bonded correctly, and I am in the correct pattern, instead of having this one where it's hot or ground reversed or open ground. So here's what we've got. So this is your switch. You've got no contact, or you got normally closed, and then normally open over here. I'm using the closed and the normally open position. These is being supplied by this 24 volt power supply. I'm going to mount this thing somewhere else, but this is just the temporary setup so you can see how this guy works. So this is what's supplying power to the relay, and this is basically just acting as a little contact closure that is closing and supplying the power to the relay. I use a 24 volt DC relay because, one, I just don't feel comfortable running 120 volts through this little contactor for driving a relay, even though it would still be minuscule amps. 24 volts DC is more than sufficient. This is the relay block. So at the top here we got power. These are operating the coil, and down here I've got, these are the two. This is the ground, and this is the neutral. And so when this guy closes, it's essentially locking these two guys together. Now this particular relay has two other contacts on it that also close as well. So you could potentially wire, multiple inverters to this. There should not be any significant amperage between being carried across these, so this should be more than sufficient, and we'll throw a ammeter on there in a moment. Now it's hard to see, but basically back there in the back, that's where your input is, or that's where your output of the inverter is. These front wires, these are your inputs. So what I have is I've got the additional ground on that ground wire. I have the additional neutral on that neutral wire, and those are what are going to that relay. And so when the relay clicks together, it's basically acting like you're putting a jumper between that neutral and that ground. And what happens is, right now, let's see if I can get this guy to show a little bit better. See, right now I am on solar and on battery. So we're going to command this guy to switch back over to the grid, and we're going to it'll basically, at that point, it would then switch back, so essentially switch off that that relay. The setting for this guy is this guy, NEC, enabled. So you go to option 24, enter, and you can choose enabled. Once that's enabled, what that's going to do is that's going to operate that contact closure from the closed and normally open down here. That is going to essentially close those things anytime it's on solar and battery. That's going to move your bonded ground to the output here, just like it is normally, essentially at your very first panel from the power company. When you're not on grid and you're flowing power from the power company through there, that bonded ground needs to be back at your main panel. This will then open up and your bonded ground flows back to it. The other thing you can potentially do, since you've got additional contactors on this, you could potentially connect up a LED on one of those other contactors, supply power to that LED, and then you would be able to know that relay has closed and you are on your relay each time. This particular little adapter for that relay block is actually designed to attach to a DIN rail. I just have it attached here for the moment so I could show you the process. This is going to move to a different spot. Probably going to put it in a little enclosure and tidy things up a little bit nicer, but this just shows the proof of concept that this does work and it works well. And I will supply all the part numbers for the stuff. I got this off of Digikey, power supply, the relay, and that little adapter. And this is it's able to handle, I believe it's 10 amps across that, which should be more than enough for what this is doing for the bonding of the ground. As you can see, I'm in the bonded position. I have my ammeter on there. There is no amperage being carried across that. So this relay will be able to handle the load just fine. Should be no issues with that whatsoever. For a little bit more detail on the power supply for this relay, so I've got this power supply. Basically, you've got the two lines coming out. Now this relay doesn't care positive or negative, as long as you supply 24 volts DC to it. On those two contacts, it opens up. So basically what that is line 1 of this power supply is going into the contactor. That's then coming back out of here, comes around and goes into here. And then this line goes back to the power supply. And so then this is basically acting just like a switch. So when it needs to turn on that contactor, it's closing these two wires together just like a switch would, and that bonds your ground at this panel. Once you're back to grid, it's essentially opening up that switch, and then that breaks the circuit, and that cuts the power to the relay. Very simple. These are a good heavy-duty relay. They should last for years. They're also easy to get on Digikey. So should not really have much in way of any kind of issues to it. This is not doing any kind of major load when it's bonding that piece together, so this is pretty much an overkill for this circuit.